Hello everyone, welcome. This educational channel expounds topics in mathematics, civil engineering, and professional education subjects. This channel aims to simplify the lessons, and I am your scholar, Bert, a Filipino licensed teacher and engineer. Thank you for watching.
Hello everyone, this is the second video on the linear equations of order 1. If you did not watch yet the first part, please watch it prior to this current discussion. Now let's move to another example. Solve the equation dx plus 2y x minus 1 dy equals to 0. Our first step again is to write the equation into the standard form. And by this time, I'm going to discuss to you that there are two possible forms. The first form is in terms of y. This is the standard form that we have in our previous two examples. However, if we are going to interchange the letter here, that will also become a standard form in terms of x. For example, instead of writing dy over dx, we can write dx over dy. And instead of px, we can have py. Instead of y, that is x. Instead of qx, then that is qy. So, with these two forms, the question is, how can we determine if the given equation is in terms of y or in terms of x? One indication is to count the number of the dy or the dx when both dy and dx are on the numerator. For example, in this equation, if you are going to multiply this equation by dx, then eventually the function of pxy is a dx term and the qx is also the dx term. So actually here, there are two dx terms. Then on the second form, you will have two dy terms. And to determine what is that form, so the term that has only one dy or one dx, that is now the letter that represent to that equation. So for example, if you have one dy term, then you have a linear equation in terms of y. If you have one dx term, then that is a linear equation in terms of x. So let's try in our example 3. We're going to expand this. So you have here dx plus 2xy minus 2y dy equals to 0. Then we are going to expand. You have here dx plus 2xy dy minus 2y dy is equal to 0. You have two dy terms and you have one dx term. As I have mentioned, if you have only one dx term, then that is an equation of linear in terms of variable x. So this is the standard form. In this standard form, you notice that the qy should only be a function of y. So in this form, you notice it might be the third term. But before doing that, we need to multiply this by 1 over dy. So we have here dx over dy plus, this is cancelled, so you have 2xy, then cancel, you have negative 2y equals to 0. Then from this, we're going to transpose negative 2y to the right side. So you have dx over dy plus 2xy equals 2y. This is now our standard form. And for our formula here is v is equal to e raised to the integral of p dx if that is in variable of y. Since this is in variable of x, then the formula here is equivalent to e integral of p, and it should be dy. Take note, this equation is for linear equation in terms of y. And since our given problem is in variable x, we have to change the dx to the other letter, that is dy. So we have here e integral of p. What is our p here? Our p, it should be the coefficient of our x. So notice we have here x, then you have here the py. So if you have here the x, then our py here, where your py, it should be 2y. So this is 2y. Then integrate integral of 2y dy, you will have here 2, then y squared over 2, then equals e, cancel, then you have here y squared. After getting the value of the integrating factor, we are now going to proceed to step 3, which is to multiply the equation and then integrate. Our equation is dx over dy plus, I'm going to copy this equation, plus 2x y is equal to 2y. Multiply this by the integrating factor, which is e raised to y squared. Then at the same time, we will have to multiply this by our dy, so that there will be no dy denominators in this equation. So multiply now this term or factor to the equation, e y squared, then we have here dx plus, multiply this one here, we have 2xy e y squared dy is equal to, we have 2y e y squared dy. Then we are going to integrate. So integrate now this term and also integrate the right side. You notice that this is an exact, and the solution for this is simply the integrating factor, which is e raised to y squared, and the integral of this dx, which is x. In our previous example, take note what we have added to the integrating factor is y, but by this time, since this is a linear equation in x, so we're going to add also x. Then, integrate the right side. We already integrate the right side similar to this one in our example 2. And the answer for this is e y squared plus the constant. This is now our final answer. At this time, instead of giving you more examples, let us have practice exercises which consist of 2 parts. The part 1 centers on identifying a linear equation. The part 2 is finding the solution. I will give you time to answer the test, and then I will give you the answer later. Nevertheless, this practice exercises activity is just equivalent to more examples, but it is better since you able to practice answering questions on this topic, and you can gauge yourself how far have you learned our discussion. So we will start the part 1. Classify the following differential equations either linear or not. If the equation is linear, determine the value of px and qx. The standard forms of a linear equation are given here. This is the standard form in variable y, and this is also the standard form in variable x. We have here 6 differential equations to be classified. The time allotted is only 30 seconds. If you need longer time, you have the option to pause this video while answering. After answering, you can play back the video to check your answer. We are now going to classify the 6 differential equations. As noticed, all the 6 differential equations are now written in standard form, since the first term are either dy over dx or dx over dy, then the rest are polynomial. In particular, our first to the third differential equations are in variable y, while the fourth to the sixth differential equations are in variable x. Now we are going to classify our first differential equation. For the standard form of a linear equations in variable y, you notice this is dy and we have only here variable y raised to the first power. For our number 1, we have here dy and we have variable y raised to the first power. Therefore, this is linear. And our value for p here is the coefficients of y. This is negative 2x. And our q is the term at the right side. That is 3. For number 2, we have here dy and we have also here y raised to the first power and the rest are function of x. Therefore, this is linear. And for our value for p, that is the numerical coefficient of y, is negative 2 over x. And our value for q is 3x squared. This is the term found at the right side. For number 3, again we have here dy, but we don't have y in the numerator. Instead, our y here is in the denominator. In short, our y here is raised to the negative 1. But in our standard form, it should be y raised to the first power. Therefore, this is not linear. For number 4, we are going to refer to the standard form of a linear equations in variable x, in which we have here dx and we have here variable x raised to the first power and the rest are in terms of y, that is py and qy. For our number 4 to number 6, we are going to refer to our standard form of a linear equation in variable x. As shown, in this standard form, we have here dx in the numerator and also x raised to the first power. Then the rest are function of y. For number 4, we have here dx and for the second term, we have here x raised to the first power. And the rest are function of y. Therefore, this is linear. For our value for p is now the numerical coefficient of x, which is negative 2y. Then our q are the function of y found at the right side, that is 3y squared. For number 5, we have here again dx, but our x here is in denominator. Therefore, this is not linear. For number 6, we have here dx in the numerator and our x here is raised to the first power and the rest are function of y. This is linear. And our value for p, the coefficient of x is negative 2y. And our q is the function found at the right side. That is 3y squared plus 2by plus 1. Overall, you notice our value for q can be monomial or trinomial. As long as for number 1 to number 3, it should be function of x, and also for number 4 to number 5, it should only be function of y. We have here another set of differential equations to be classified. The time allotted is 30 seconds. Similar to the previous, if you need longer time, you can pause this video and play this again after answering. We are now going to answer number 7 to number 12. For number 7 to number 9, you notice this is somehow a linear equation in variable y, since the numerators are dy. And for number 10, this is somehow a linear equation in variable x, since the numerator is dx. In particular, for number 7, we have here dy, and we have also here y raised to the first power, and the rest are functions of x. Therefore, this is linear. And the value for p here, or the coefficient of y, is negative 2 plus x. As observed, our value for p here is a binomial. Unlike to our previous examples, our value for p is monomial. I purposely give this example to you to emphasize that our value for p is a polynomial and not a monomial, meaning we can have here a binomial, trinomial, or a polynomial containing of 4 or more than 4 terms. Then our value for q here is 3. This is the term found on the right side. For number 8, we have here dy, and we have here y squared. Since the exponent is 2, therefore, this is not linear. For number 9, this is dy, and we have here y raised to the first power. However, the rest are not only function of x. We have here y. Therefore, this is not linear. For number 10, this is a linear equation in variable x. We have here dx, and we have also here x raised to the first power. Supposedly, the rest functions are function of y, but on the right side, we have here function of x. Again, this is not linear. For number 11, our equation is not in the standard form. Nevertheless, if we have only 3 terms, it is easy for us to identify either it can be a linear equation in terms of y or in terms of x. How? If you have one dy term, then that is in variable y. Unlike in number 12, you have only one dx term. So this number 12 is a linear equation in terms of x. We can prove this concept if we are going to expand our standard form. For example, in our linear equation in variable y, the equation is dy over dx plus pxy is equal to qx. If we are going to multiply this by dx, we have here dy plus pxy, then dx is equal to qx dx. So we have here 3 terms and only one is the dy term. The rest are dx term. Then if we have linear equation in variable x, the standard form is dx over dy plus pyx is equal to qy. I'm going to multiply this by the dy. Then this is cancelled, so you have dx plus pyx dy is equal to qy dy. Again, out of the 3 terms, you have only one dx if that is a linear equation in terms of variable x. So again, for number 11, since you have only one dy term, that is in variable y, and for number 12, that is in variable x since you have only one dx. Then we are going to find out if this is really a linear equation. For number 11, dy minus 2xy dx is equal to 3x dx. I'm going to multiply this equation by 1 over dx. We have here dy over dx minus 2xy. Take note, dx is cancelled, is equal to 3x here. Dx is also cancelled. So as shown, this is a linear equation in variable y. This is our dy, and this is y raised to the first power, and the rest are function of x. Therefore, this is linear. And our value for p is the coefficient of y, which is negative 2x. Then the term at the right side is our value for q. For number 12, we have here dx minus 2x dy minus a y squared dy is equal to 0. I'm going now to multiply this by 1 over dy. So we have here dx over dy minus dy is cancelled. We have here 2x minus dy is also cancelled here. So we have here negative a y squared is equal to 0. Then I'm going to transpose negative a squared to the right side. So we have here dx over dy minus 2x is equal to positive a y squared. As shown, we have here dx and we have here x raised to the first power. This is linear equation. And our coefficient of x is negative 2. Then our value for q is a y squared. Let us now proceed in finding the solution of a differential equation. Solve the equation dy over dx plus 2y over x is equal to 6x cubed. I will give you 30 seconds to answer this problem. If you need longer time, you may pause this video while answering, after which you can play back this video to check your answer. Let us now find the solution of the given equation. For step 1, write the equation into the standard form. As shown, the given equation is already in standard form. This is in variable of y. We have here dy and we have y raised to the first power. From this, our value for the function of px is equivalent to 2 over x, and our q is 6x cubed. For step 2, determine the integrating factor. Our formula, v is equal to e raised to the integral of p dx. We have here e, the integral of, let us substitute the value of p, that is 2 over x. So we have here 2 over x dx. Then it is equivalent to e, and integral of 2 dx over x, use the ln formula, and that is equivalent to 2 ln of x. Then simplify the exponent, that is e, using the ln property. This is expressed as ln of x squared. And finally, this is equivalent to x squared. For our step 3, multiply the equation by the integrating factor and integrate. Our equation is dy over dx plus 2y over x, that is equal to 6x cubed. Then multiply by our integrating factor, that is x squared. At the same time, we're going to multiply this by dx. So for the first term, dy over dx multiplied by our multiplier, we have here x squared, then dx is cancelled, so you have here dy, plus 2y over x multiplied by x squared dx. One of our x here is cancelled, so you have here 2x y dx is equal to 6x cubed times x squared dx is 6x raised to the 5th power dx. As noticed, the left members is already an exact, so we can integrate that directly. So that is integral of x squared dy plus 2xy dx. And the answer for that is equivalent to the integrating factor. Our integrating factor is x squared and the integral of our dy, which is y. As checking, the differential of x squared y is equivalent to x squared dy plus 2xy dx. We are using here the product formula. Then we can integrate here 6 integral of x5 dx. So we have here 6. Then integral of x5 is x raised to 6 over 6 plus the constant. Then simplify, we have x squared y is equal to x raised to 6 since these are cancelled plus the constant. This is our final answer. Hello everyone! This is the end of our discussion on the linear equations of order 1. You can now proceed to the next video, which is the integrating factors found by inspection.